If you are someone who is looking for a job in the domain of data analyst, data science, or even software development, then this video is going to be a gold mine for you. In this video, we'll cover top 50 Python conceptual as well as coding questions often asked in Python interviews. We'll cover a range of beginner to intermediate level questions. If you haven't subscribed to our channel, please do it now to see more of our data tech learning content in your YouTube feed. At this point, let's get started. Why is Python called an interpreted language? Interpreted language means any programming language which executes instructions directly and line by line. It means it does not compile the program like C++ or Java does. Rather, it directly runs the complete program all at once. And while running the program, wherever it encounters an error, it stops. And if you think about it, this makes Python easier to debug because you get to know exactly where the error occurred in your code. Now, Python doesn't need a separate compilation step like C++ or Java. You can just write Python code and run it directly. Here's what it means. C++ or Java is required to be built and linked. Building process involves using a compiler to translate the human-related source code into machine-readable object code files. The linking process combines these object code files together into a final executable program. These steps are necessary in languages like C++ or Java to produce an executable program that a computer can thereafter run. On the other hand, in Python, you can directly run the code without going into any of these separate steps. You can just write Python code and run it directly. This is the precise reason why Python is fast to develop as well. Do we need indentation in Python? The obvious answer is yes. You need indentation because it is part of the language's syntax. Now let's understand why. Indentation helps in reading the code better, and that is why Python has made it compulsory. Every programming language provides mechanism to manage and control how the coding blocks are written. In Python, it is indentation, and it is different in Java. For example, in Java, when we need to construct a for loop, we have to put the blocks or statements inside the for loop within the braces. And the statements inside the for loop need not be indented. It can be in the same line. But when it comes to Python, the print statement inside the for loop should have spaces, that is 4 spaces. That is how indentation works in Python. What are built-in data types in Python? In Python, a data type defines the kind of values a piece of data can have and what operations can be performed on it. Let's understand in this way. Imagine different kinds of containers, a jar, a jug, a box, and a basket. Now, each container is suitable for holding different kinds of things. You wouldn't put water in a basket, right? It's for things like fruits. Similarly, in Python, you use different data types to hold different kinds of values like integers or strings. Now, let us look at various data types we have in Python. We have text type, we have numeric types, sequence types, map types, set types, boolean type, binary types, and none type. And in Python, in case you want to know the data type of a variable, just use the type function. Let's see how it works. Now, in output, you will see the data type of the variable. The type function basically takes the variable as an argument and gives the data type of the variable. Why do we need different data types in Python? Can't we just use one type for everything? Well, that's a great question. Imagine you are packing for a trip. You wouldn't use the same suitcase for your clothes as you would for your fragile souvenirs, right? The same concept applies to data in Python. Different data types act like specialized suitcases for different kinds of information. So first comes efficiency. Let's say you have a variable to store someone's age. It would be a waste of space to use a complex data type that could hold massive amounts of data when a simple integer or a whole number type is perfectly sufficient. This helps Python use memory efficiently, which is especially important for larger programs. Another important factor is accuracy. Think about calculations. If you are working with prices that might have decimal places, you wouldn't want to use a data type that can only store whole numbers. Finally, you need to think of readability. Using appropriate data types make your code much easier to read and understand. both for you and anyone else looking at it. How can we check the data type of a variable in Python? Well, that's where the type function comes in. Think of type function as a handy label checker. Just like label on your luggage, type tells you what kind of data a variable holds. It's super easy to use. Let's say we have three different variables: age, name, and is happy. For checking their data types, all you need to do is to call the type function on them. Type ensures you are using the right data type for calculations and operations. What are Python sets? Explains some of the properties of sets. In Python, a set is an unordered collection of unique objects. Sets are defined using curly braces. Each and every value is separated by commas. And you know what is more interesting? It is not ordered. For example, we give input apple, banana, cherry, and while giving output, the order is changed. So as you can see, it is not ordered. Similarly, sets are often used to store a collection of distinct objects. That means they automatically remove duplicate values. For example, over here, we have defined a set having elements apple, banana, cherry, orange. And if we add another element to this set, in the output you will see apple is not repeated twice. Now, sets are also used to perform membership tests, that is to check if an object is indeed present in a set. And this is how it is done. And for this piece of code, the output is yes, because banana is definitely present in the fruit set. Now let's move on to the properties of sets. First one is sets are unordered, as I explained. Secondly, sets are unique. Third is sets are mutable. So you can add or remove elements from a set using the add and remove methods. And fourthly, sets are not indexed. Sets do not support indexing or slicing, so you cannot access individual elements of a set using an index. What is the difference between list and a tuple? List and tuple are essentially data structures. So let's first understand what data structures are in Python. Data structures are a way of storing and organizing data efficiently. Why is this important? When you store your data in an unorganized manner, this will allow you to easily access and perform operations on the data. Now, you will want to store data in different ways to cater to the need of the hour. Maybe you want to store all data types together, or you want to store data in such a manner which will help in faster retrieval, or maybe in some ways that stores only distinct data items. Luckily, Python has a host of inbuilt data structures. Out of all, list and tuple are two types of built-in data structures that are used to store collections of data. Now let's look at the differences. First is mutability. Lists are mutable. They can be modified after creation, so you can do adding, removing, changing items, etc. Whereas tuples are immutable. Once they are created, their content cannot be changed. Second difference is syntax. Lists are defined using square brackets, as you can see, and tuples are defined using parentheses. Again, you can see. Third key difference is performance. Lists take up more memory due to their ability to change and grow, whereas tuples are more memory efficient and usually faster because they are immutable. And this is how a list looks like. And this is how a tuple looks like. Explain the difference between mutable and immutable objects in Python. For this, let's first understand what an object is in Python. In Python, almost everything is an object, including numbers, strings, lists, dictionaries, functions, and even modules. Now, objects can be of two types, mutable and immutable. If you remember correctly, we have already talked about this when we were talking about list being mutable and tuple being immutable. Now, let me talk about this in detail. So, what does mutable means? These are objects whose content or state can be changed after they are created. We have seen an example of a list which is a mutable object before. We have seen an example of a list which is a mutable object. Now, let's see a different example with a dictionary. In this example, we have a dictionary called student, and we modify the value associated with the key age from 25 to 26. We also add a new key value pair, gender, female, to the dictionary. Because the dictionary is mutable, so its content can be changed and updated as needed. Moving on, what are immutable objects? Well, these are objects whose content or state cannot be changed after they are created. If you try to change the state, you will actually create a new object. We have seen how a tuple looks like. Another example of a mutable object is a string. As you can see in this code, trying to directly change the character at index 0 in the string name will raise a type error because strings are immutable. Instead, we need to create a new string, modified name, with the desired change, which is replacing the first character with m. What is a dictionary in Python? Dictionary is an unordered collection of elements. In other words, a dictionary in Python is a built-in data structure for storing collections of objects or values. These elements in a dictionary are stored as key value pairs. This means there is a specific key and there is a value which is assigned to a key. This is pretty much like a real life dictionary where you look up a word known as the key to get its definition on a specific page which is known as the value. For example, in the dictionary, my dictionary over here, the key is name and the value for the key is John. In this example, name, age, city are the keys, and John, 30, and New York are their respective values. This dictionary represents a person, and we can use it to look up details about the person like their name, age, and city. By the way, dictionaries are mutable in nature. You can modify the dictionary by adding, changing, or removing key value pairs as shown in this example. How to access an element of a list? In Python, lists are ordered collection of items. Accessing individual elements within a list is straightforward using square brackets and the element's index. Indexing starts from 0. The first element in the list has an index of 0, the second element has an index of 1, and so on. Coming on to the solution, we create a list called mylist containing numbers 10, 20, 30, 40, 50. Let's initialize this. To access the first element, we use mylist and we put 0 as the index value in the square brackets. Let's see what we get. So first element from the list is printed. Similarly, for third element, we declare index as 2. You can also access the last element using mylist -1. This is a special way of referring to the last element in the list. So let's see what we get. And we are indeed getting the last element. Convert a string to integer using a single line of code. Imagine you have some number stored as a string like 1, 2, 3, or this 5 over here stored in variable a, and you want to use it for calculations. But computers can only perform operations on numbers, so we need to figure out a way to convert this string into a number first. So over here in this particular code, let's say we have a variable a having this string assigned to it. I'll just initialize this. In a single line, we use the int function. Inside the parenthesis, we pass the variable a, which holds the string value. This function attempts to convert the string content to a corresponding integer, and finally, we print the number. Similarly, if you want this integer value to be stored in a separate variable, you can do that too. Write a code snippet to convert a string to a list. In Python, converting a string into a list is a common task. You can achieve this using the built-in split function. This function splits the string based on a specific separator, effectively creating a list of individual elements from the original string. So here's how we can use the split function. First of all, we define this variable string1 and assign the value analytics vidya to it. We then use the split method on string1. By default, the split function uses any white space character, including spaces, tabs, and new line as the delimiter. This means it will split the string at every white space, creating a list of individual words. And using this print function, we observe the result. What are the different comparison operators used in Python? So this is another essential concept, which is comparison operators. Comparison operators act like judges in your Python code, comparing values and returning verdicts of true or false. They help you make decisions and control the flow of your program. Here are some common comparison operator in your Python arsenal. So namely, there is equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. Here's a quick exhibit of operators in action with this Python code snippet here. What are the benefits of using functions in Python? To start with, think of functions like tools in your coding toolbox. You create a function once with a specific task like calculating an area or checking if a number is even. Then you can reuse that function throughout your program whenever needed. This reusability part is fantastic. It saves you time and effort by not rewriting the same code multiple times. It also keeps your code organized and modular, making it easier to understand and maintain, especially for complex programs. Functions also improve code readability. You can give them descriptive names that hint at their purpose. This makes your code self-documenting, like labeling tools in your toolbox. So functions are like code superheroes, prompting reusability, organization, and readability. What are Python functions and how do they help in code optimization? A function is a block of code that can be called by other parts of your program. In other words, it's a piece of reusable code that you can run whenever you need it instead of writing the same code multiple times. So how do you write a function? First, you define functions using the def keyword followed by the function name, parenthesis, and a colon followed by it. The code block within every function is indented, and this is how a function looks like. In this example, add numbers is a function that takes two parameters, number 1 and number 2, adds them together and returns the result. When we call add numbers 3, 5, it executes the code within the function and returns the sum of 3 and 5, which is 8. So how does it help in code optimization? Well, functions allow you to reuse code by encapsulating it in a single place and calling it multiple times from different parts of your program. In this example, say hello is a function that doesn't take any parameters. When we call say hello, it simply prints hello world. And what else? Well, functions give improved readability to your program. By dividing your code into logical blocks, functions can make your code more readable and easier to understand. It also reduces redundancy of your code and makes it cleaner and readable. Functions also make code easier for testing. Functions allow you to test individual blocks of code separately, so you can debug individual functions independently of the rest of the code. It also provides improved performance. Functions can also help to improve the performance of your code by allowing you to use optimized code libraries or by allowing the Python interpreter to optimize the code more effectively. What is indexing and what is negative indexing? We need to understand the concept of iterables first before we get into indexing. It is a special type of object in Python that can iterate over. What do I mean by that? Well, you can cross or go through all the different elements or entities contained within the object. And the object could be a list, a tuple, a string, dictionary, etc. are all iterable in Python. And yes, the iteration part could easily be achieved with the help of for loops. So in simple words, iterables are something you can loop over. Now, when we understand what iterables are, now let's focus on indexing. Indexing is basically a way to access individual elements or groups of elements in an iterable by their position. In other words, you can access a specific element of your choice within an iterable, such as a list, and do your operations with it depending on your needs. Let me show you how. I have this list of strings with various fruit names. In the very beginning, Python allocates memory for the list and each element is indexed this way. In Python, indexing starts from 0, as you can see. So if you have a list called my list, having elements like apple, banana, cherry, the index of apple is 0, banana is 1, and cherry is 2. And this indexing that we have discussed is the one which is generally used and is called positive indexing. Now, what is negative indexing? Negative indexing simply means the last element of the collection has an index of -1 and the second last has -2 and so on. Explain slicing in Python. Slicing in Python is a feature that allows you to access a subset or a slice of a list or a sequence. In other words, slicing a list gives you another list instead of a single element. This means Each object in the list has a specific index. Slice specifies a start index and an end index of a list. For example, in the list, apple has an index of 0, banana has an index of 1, cherry has index of 2, and so on. Now I want the fruit banana, cherry, and date from the list. We would need to slice it out from the list. So we slice it out over here. By the way, keep in mind that the sublist returned will contain the elements starting from the start index but will exclude the end index element. So we see the output is basically banana, cherry, and date. One more thing, if you leave out the start index, it will assume it to be 0. And if you leave out the end index, again, the output will be the entire length of the list. Explain the logical operators in Python. In Python, the logical operators and, or, and not can be used to perform Boolean operations. This is done in order to determine whether a condition is true or false. What do I mean by this? Well, in Python, there can be situations where there are two or more conditions and we need to check which condition is true and which is false. And for these situations, we use logical operations. There are three types of logical operators: and, or, and not. The AND operator returns true if both operands are true. If either condition is false, it returns false, like this. Then OR operator returns true if at least one of the operand is true. If both conditions are false, it returns false. Right, thereafter, NOT operator returns the opposite of operand. If the condition is true, it returns false, and if the condition is false, it returns true. Logical operators are often used in control flow constructs such as if, elif, and while statements to combine conditions and make decisions based on multiple criteria. What are classes and objects in Python? In Python, a class is a blueprint for creating objects. On the other hand, an object is an instance of a class. What do I mean by this? Well, class can be considered to be your blueprint and objects are real-world entities which are defined or created from classes. Let's take an example here. This is a blueprint of a house. The blueprint defines the layout of the house, the number of rooms, the type of rooms including kitchen, bathroom, bedroom, etc., the material used, etc. And now with this blueprint, we can create an unlimited number of houses. An object, on the other hand, is an instance of a class. It's a real tangible thing that you create using the blueprint. Over here, it is house 1, house 2, and house 3 are in fact objects, actual houses, created from the house class, which is the blueprint. They have the structure defined by the house class. Checking for leap year is a very common question asked in interviews. Let's understand what a leap year is, first of all. A leap year is a calendar year that contains an additional day compared to a common year. This means a leap year has 366 days instead of the usual 365. Now, every year that is exactly divisible by 4 is a leap year. However, except for years that are exactly divisible by 100. These are centurial years. These centurial years are leap years if they are exactly divisible by 400. For example, the years 1700, 1800 and 1900 are not leap years, but years 1600 and 2000 are indeed leap years. Now let's see how to calculate a leap year in Python. As a very first step, the code takes an integer input from the user representing the year to be checked. Then we check if the year is a century year and is divisible by 400. If both conditions are true, the year has to be a leap year. Next up, we check if the year is not a century year but is divisible by 4. If both conditions are true, again, the year is considered a leap year. If the year does not meet the conditions specified in the above two conditions, it is not a leap year, and then the else part is executed. Based on the year, the output says whether the number is leap year or not. Let's run the code and see it in action. Let's try 2024. As you can see, we are indeed in a leap year right now. How to use a Python program to check whether the given number is an Armstrong number or not. Let's first understand what an Armstrong number is. An Armstrong number is a number that is equal to the sum of the cubes of its own digits. For example, this 153 is an Armstrong number because 1 raised to power 3, 5 raised to power 3 and 3 raised to power 3 equals 153, which is the number itself. Now let's see how you can write a Python program to check if a number is an Armstrong number. For this, again, we take an input from the user. The number has to be an integer. This is followed by initializing a variable sum to store the sum of the cube of each digit. Then we create a temporary variable and assigns the value of num to it. This is done to preserve the original value of num for later comparison. Thereafter, we initiate a while loop that continues as long as temporary variable temp is greater than 0. Inside the while loop, we extract the last digit of the current value of temp using this modulus operator. Then we add the cube of the extracted digit to the variable sum that we declared above. And finally, we remove the last digit from the current value of temp. For example, let's say we declare the input value as 153. So as first step, from 153, this particular line of code will extract 3, which is the last digit. Thereafter, with this second line of code, that 3 will be raised to the power 3. So 3 times 3 times 3 is 27. So sum becomes 27. And thereafter, with this third line of code, we are doing float division that removes the last digit 3, and we are left with a temporary number of 15. Now we check if num is equal to sum. It means that the number is an Armstrong number, and if it is not, the number is not Armstrong. Let us run the code now and check its functionality. Let's insert 153, which is indeed an Armstrong number, and we get 153. Another number we can try is 1. 1 raised to power 3 is again 1, so it should be an Armstrong number as well. This question asks to write a Python program to check whether a string is palindrome or not. So you may ask, what is a palindrome? Well, a palindrome is a word, number, phrase, or other sequence of symbols that read the same backwards as forwards. For example, words such as madam, race car are palindromes. Now let us look at the program to check if a given string is a palindrome. So to do that, first of all, we ask the user to enter a string and store its value in this variable myString. Thereafter, we are calling this method caseFold onto our input string to reduce it to lowercase so that it is suitable for caseless comparison. Thereafter, we use the reversed function to reverse the string and store it in this second variable called reverse string. As last step, we check if both the strings are equal. If they are, we print this particular statement that the string is a palindrome. Otherwise, we say the string is not a palindrome. Now let's see this code in action. Let me first pick this word EYEI, and as we can see, it's a palindrome. Now, just for validation, let's pick up another body part, ear, and as we can see, it is not a palindrome. So our code is working fine.
Now, let us understand why we need Python reverse string. The ability to reverse and return strings is not only useful in programming, but can also come in handy in everyday life. For example, you may want to reverse the order of characters in a string to create a palindrome, or in encoding or decoding where reversing a string can help in the process.
How to swap two numbers in Python? This is a very simple and very common question. Number swap can be done in two different ways. First one is a traditional method using the variable temp. The second one, on the other hand, can be done to save time. Let's begin with the traditional method at this point. All right, now let's jump into the hands-on. First of all, we are declaring the two variables x and y, where x is equal to 5 and y is equal to 10. Thereafter, we create a temporary variable called temp to swap the values. Let's put the value of x into the variable temp. After that, we put the value of y into x. And finally, we put the value of temp into y. At this point, we are done with our swapping. Let's print the value of x and y. And as you can see, the two numbers have been swapped. Now let's look at the second method for swapping two numbers. This particular method specifically applies to Python and is not supported by all the programming languages that are out there. So in this second method, again, we declared two variables x and y, x equal to 5 and y equal to 10. This time, we use a single line of code for swapping the variables. We just say x comma y is equal to y comma x. This effectively swaps the value with just a single line of code. Now let's print the values to see if it has happened. And yes, our numbers have gotten swapped. How to check if a number is prime number or not? This is a very common question asked in interviews. Do you remember what the prime number is? Well, if not, I'll tell you. Prime numbers are natural numbers that are divisible by 1 and by themselves. Now, let's see how to check if a number is prime number or not. To do that, first up, we define a function named isPrime. This function will check whether a given number is prime or not. This function takes one argument as input, and depending upon the number that we pass within the function, we are first checking if the input number is less than 2. If it is, we return false, indicating that it's not prime, as 0 and 1 are not prime numbers. Now, to determine if a number is prime, we will then check for factors from 2 up to the square root of the number. Let's use a for loop to do that, as we are doing over here. Inside the loop, we check if the input number is divisible by the current number. This will return false if we find another factor than 1 and the number itself. And if the loop complete without finding any factors, we return true, meaning that the given number is a prime number. I hope the functionality of the prime function is now clear to you. I'll quickly initialize this. Now let's call this function on a given number to check if the number is prime or not. Let me try 4, and the function says 4 is not a prime number. Now let's try 7, and it indeed is a prime number. How to find out the factorial of a given number? Finding out the factorial of a number, that is another beginner level question asked in interviews quite often. Now, if you guys have forgotten what a factorial of a number is, a factorial is a function that multiplies a number by every number below it till 1. For example, the factorial of 3 represents the multiplication of numbers 3, 2, and 1. That is, 3 factorial is equal to 3 times 2 times 1 and is equal to 6. Now let's look at the Python code to compute factorial of a number. Again, to compute the factorial of a number, I'll be sharing two different methods with you. In the first method, we define the function called compute factorial. Within the function, we initialize a variable called factorial and assign value of 1 to it. Thereafter, we check for various conditions. Now we are going to check whether the number is negative, positive, or 0. If it is negative, then we'll say its factorial doesn't exist because it's a negative number. And if it is 0, then its factorial is 1. If the number is positive, we create a for loop, as is the case over here, that iterates from 1 to the number which is provided as input. And with this line of code, we compute the factorial. And then we print the final factorial value with this print statement. Let's initialize this function. Now let's call this function on a given input number. Let me start off with a simple number, let's say 3. And we know that factorial of 3 is 6, so it's correct. We may even try out a bigger number, let's say 50. And this is the factorial value of 50. Now, this method number 1 is having a simple logic to it, but it's not an efficient way of computing factorial. Just think about it. Every time we ask for a factorial of a number, the function starts from scratch and does all the calculations. While it seemed to be not much of a problem for smaller numbers, the problem spirals out as and when we input a larger number. Now, a simple solution to this issue is to introduce memorization, which is a technique to store and reuse previously computed results to optimize recursive calculations. And that's exactly what we are doing in this method number 2, which is over here. Let me take you through this. First up, we initialize an empty dictionary called Memo. This dictionary will be used to store previously computed factorial values for various integers. Then we define this function called factorial memory, which takes an integer n as argument. This function calculates the factorial of n using memorization. Within the function, we first check if number is 0. If it is, we return factorial equal to 1, as we discussed previously. If number is not 0, then we check if factorial of n is already computed and stored in Memo with these two lines of code. If it is, then function returns the pre-computed value instead of recalculating it. This is largely the essence of memorization, which saves time by reusing previously computed results. Moving on, if the factorial of n has not been computed and stored in Memo, this particular line calculates it recursively. It multiplies n by the factorial of n minus 1 and then stores the result in the Memo dictionary under the key n. Finally, the function returns the calculated factorial value, whether it was computed in this call or retrieved from Memo if it was previously computed. Now let's try out this functionality in this next code cell. All right, I'll run this. Let's start off with a small number. I'll say 3. And we get the correct answer, which is 6. Now, just to give you an additional layer of insight here, let me print this dictionary to see what's going on inside it. And as you may see, the factorial values of 1, 2, and 3 have gotten stored within this dictionary as key value pairs. So for all of these three numbers, if I ask the function to compute factorial of these, the function will not do the calculation, rather retrieve them directly from the dictionary memo. And not just that, I can even query for larger numbers to compute their factorial. Let's say 50 once again, and we get this huge number as output. And if I print memo again, you will see that all of the numbers till 50 have gotten stored in this dictionary. Quite handy, right? How to generate random numbers in Python. Over here, we will try to understand how to generate random numbers in Python. Look, at some point when you are doing real life projects in Python, you need to generate random numbers for some specific work. There are quite a few ways to do this, and here we will discuss 4 different ways of generating random numbers depending upon various use cases that you may come across. For generating random numbers, Python has an inbuilt module called random. So right at the onset, we are importing it. As first use case, let's say you want to print a single random value, which is a float between 0 and 1. For that, we use the random method. Let's run this. And as you can see, we get a float between 0 and 1 using this method random. Moving on to the second use case, let's say you want to print a float between a specific range, let's say 1 and 100. For that, we use the uniform method. Let me run this. And as you can see, we are getting a float value, but this time between 1 and 100. As third use case, let's say you want to print a random integer this time, again in a specific range. For that, we use the method randint. Let me run this. And as you can see, we are getting a random integer this time between the specified range. If I run it again, we are going to get a different random integer. Moving on, let's say our use case is to generate a random number in a range with incremental steps. For that, we use the randRange method. It has start, which is this, a stop, which is this, and the step. We can use this to print random even or odd numbers in a given range. For example, let's say we want to print even numbers between 0 and 100. In that case, I'll define my step to be equal to 2. And every time I generate a random number with this line of code, I'll always get an even number. All right, moving on to the last use case. All of these codes that we have discussed till now give a single random number every time we call them. Now, to print a series of numbers randomly, we use the sample method. For using the sample method, we first of all define a range. Again, let's say between 0 and 100, and the number of random numbers that we want to generate. If I run this one, we'll get 3 random numbers generated. So that is all about random numbers. Next time when you are asked about how to print random numbers, I hope you can answer that question. Print the first 10 numbers of Fibonacci series in Python. Now, for solving this one, first of all, let's understand what a Fibonacci series is. Fibonacci sequence is a sequence in which each number is the sum of the 2 preceding ones. And by the way, it is not just a classic programming exercise, it is also a great way to explore recursive and iterative techniques in programming. Now let's print the first 10 numbers of the Fibonacci series. All right, to compute Fibonacci series, we write this function called print Fibonacci. Right on top, we initialize 2 variables a and b, set them to 0 and 1. These are basically the first 2 numbers in our Fibonacci series. Then we use a series of if conditions, as you can see over here. First of all, we are checking if the input number is less than 1, which means nothing is to be printed. If it is equal to 1 or it is equal to 2, accordingly we print a and a plus b according to the if statements. If the number is more than 2, we print a plus b, and for the remaining values we use a for loop to generate and print the next values in the series. Inside the loop we calculate the next term, which is c, by adding the previous two numbers a and b. Then after calculating c, we update the value of a and b according to this. In this place, a takes the value of b and b takes the value of c. We have done this in the first question too, if you could remember, wherein we swapped two numbers. This prepares them for the next iteration of the loop. Now let's run this code. And now let's say we want to print the first 10 numbers of the Fibonacci series. So for that, I'll say 10. And the first 10 numbers have gotten printed. How to find the square root of a number. First, let's understand what square root is. The square root of a number is a value that when multiplied by itself gives you the original number. For example, the square root of 9 is 3 because 3 multiplied by itself equals 9. Now let's see how we can find the square root of a number in Python. Alright, first we'll see how to find the square root of positive numbers. At the beginning, we take an input from the user and convert that particular input number into a float. Then we calculate the square root of the entered number using the exponentiation operator or power operator. Using this, we simply raise the input number to the power of 0.5, which is equivalent to taking the square root. Finally, the result is printed up to 3 decimal places. Let's run the code and see what we get. Let's say we want to calculate square root for 25, and as you can see, our program is returning the square root of 25, which is 5. Now next up, we'll see how to find the square root of a complex number. For this, first we will import a Python module called cmath with this line of code. Cmath basically provides function for working with complex numbers in Python. Why are we doing this? It's essential for calculating the square root of complex numbers. Thereafter, we define the variable num with a real part, which is this, and the imaginary part, which is this. Over here, j represents the imaginary unit in Python. After that, we make provision for the user to input the number as well, if that is how you want the input to be like. Thereafter, this cmath.square root function is called to calculate the square root of the complex number. The result is stored in the variable num square root and finally printed. Now let's see how this works. As you can see, we are able to compute the square root of a complex number with this. In this question, we'll write a Python program to interchange the first and last element of a list. Before we begin, let's understand what a list is in Python. Lists are built-in data structures that are used to store collections of data. Lists are mutable, which means they can be modified after being created. This basically means that we can add, remove, change elements from a list even after when it is created. Lists are defined using square brackets. Now let's see how we can interchange elements in a list. For this, first of all, we are declaring an empty list with the name A. Thereafter, we ask the user how many elements are to be kept in the list. We'll keep 4 elements. Let's do that. So I'll just say we want to keep 4 elements in our list. Thereafter, we have a for loop here. This loop iterates n times. N basically is the number of elements we declared, which is 4. So in this step, we'll be prompted 4 times to declare the 4 elements of this list. Let's keep it simple. I'll just say 1, 2, 3, and 4. By the way, you may also feed string values rather than numbers. So now just to see how our list looks like, we can print it. This is how it looks. Now to swap between first and last element, basically this 1 and 4, we use this line of code. Over here, we basically say the first element, last element equals last element and then first element. By the way, guys, just so you know, this technique is only specific to Python. It's not a generalized technique for all programming languages. If you want to go with a traditional approach, we may also use a variable called temp, wherein we may store the first element in temp, then store the last element in the first and then dump the temp value in the last sort of element. This is sort of a traditional approach that we can take as well. Anyways, as a final step, we print a message indicating that a new list is about to be displayed and print the modified list. Let's run this code and see what we get. As you can see, the numbers have gotten swapped. Why is indentation so important in Python compared to other languages? Well, unlike some other languages that use curly braces, Python relies on indentation, basically spaces or tabs, to define code blocks. It might seem strange at first, but trust me, it's like a secret handshake that makes Python code clean and readable. Think of indentation as a visual map of your Python program. It tells Python exactly which line of code belongs together within loops, conditional statements like if and else, and functions. Incorrect indentation throws a wrench in the works, leading to errors. Here's how indentation works. See the difference? The first example used proper indentation to define the if and else blocks, while the second one is indented incorrectly, which would cause Python to complain. What is the difference between a module and a package? Now, this is a very common question asked during interviews. Modules and packages in Python are responsible for implementing the modular programming paradigm. First, let's see what a module is. Module in Python is simply a .py file containing Python code. It can contain any number of functions, classes, and variables. It is a very common practice to put together a set of related functionalities together so that you can reuse them whenever you want. Now, how do you do that? Once a module is created, it can be imported and used in another Python script using the import statement. Once you use this syntax, this will import all the functions, classes, and variables that are present inside that module. Let's see how a module is used. First, we'll create a file called math.py. This will contain functions of arithmetic operations, that is addition, then multiplication, subtraction, and division. Then we create another file called arithmetic.py, where we import the maths.py file at the very beginning. We do that by writing import maths, as you can see. Now, let's see how it works. We assign a value of 2 to x and 3 to y, and thereafter we call add and multiply functions from the math module. And as you can see, the output we get is what is expected, 5 and 6. Now, what if I want to add more complex functionalities? For that, I need to create another file and import it as another module. But just imagine how repetitive it would be if we have to import 10 such modules. Now, there is a solution for that. We put together all the related modules inside a directory and we call it a package. So a package in simple terms is a collection of modules. It is a way of organizing related Python modules into a directory. Basically, it's a directory that contains multiple module files along with a standard file called init.py, which tells Python that the directory is indeed a package. What is the use of decorators in Python? In Python, decorators are a special kind of function that add extra functionality to another function. What do I mean by this? Well, they provide a way to wrap a function with another function, which can add functionality before or after the original function is called without permanently modifying it. Let me show you how. When you call say hello, it's not directly called anymore. It's now wrapped with the wrapper function inside my decorator. The my decorator syntax is just an easier way of saying say hello equal to my decorator say hello. Now let's look at the output. In this example, my decorator is a decorator that takes a function as input and defines a new function wrapper that adds some code before and after calling function. The @myDecorator line in Python's decorator syntax for applying the decorator to the say hello function. What is exception handling and how is it done in Python? Well, exception handling in Python involves using special blocks of code so that it can catch and handle errors or exceptions that occur when your program runs. Basically, it is done to help your program keep running even when something unexpected happens. The main keywords for exception handling in Python are try, except, finally, and raise. At this point, let me show you how it works in this code. If you enter a valid integer, it prints the number, and this gets executed no matter what. Whereas if you enter something that's not a valid integer, like a string or a float, it raises a value error. The exception that moves to the except block prints that's not a valid number, and then this gets executed no matter what. The finally block is optional and is used for code that you want to be executed no matter whether an exception occurred or not. What is inheritance in Python? Also, what is the difference between single and multiple inheritance? Well, in Python, inheritance is a way to define a new class, also called a child class, that takes on attributes and methods from an existing parent class. What do I mean by this? Imagine a family where a child inherits traits from their parents like their hair color or height. In Python, inheritance works similarly. A child class can inherit characteristics and behaviors from a parent class. Now, there are two types of inheritance: single inheritance and multiple inheritance. Single inheritance is when a class inherits from a single superclass or a parent class. Think of it as a child who inherits traits from one parent. Let me show you how. In this code, child is inheriting from the parent. It means child class has all the methods that parent has plus any additional methods as defined. Now let's see what multiple inheritance is. Multiple inheritance is when a class can inherit from more than one superclass or parent class. In our analogy, imagine a child who can inherit traits from both parents. In this case, child is inheriting both from the mother and the father. So it has access to the methods from both classes. The order of inheritance matters in multiple inheritance. So if both mother and father had a method with the same name, the method from mother would be used because mother appears first, which is explain the difference between is and the equality operator in Python. The equality operator checks for value equality. It compares the values of the two objects and returns true if they are equal and false if they are not equal. It is basically a comparison operator that checks for equality. It compares the value of the two objects to determine if they are equal. In this case, list 1 and list 2 are two different objects, but they have the same value. Therefore, list 1 is equal to list 2 is actually true. Now, is checks for identity. It returns true if both variables point to the same object and false otherwise. Basically, it checks whether the two variables point to the same object in memory, not their content. In this case, list 1 and list 2 are pointing to the same object in memory. So list 1 is, list 2 is. What are generators? Tell about their use in Python. Suppose you want to make a huge list of numbers from 1 to a billion. If you create a list for this, it will consume a lot of your computer's memory, which is not efficient at all. Instead, what you can do is you can create a generator that produces these numbers one at a time and only when they are needed. This way, you only need memory for one number at a time, not all billion numbers together. Well, the official definition goes something like this. A generator in Python returns an iterator that produces sequences of values one at a time. We use the yield keyword to produce values. Now let's see how it works. In this example, count up to is a generator that counts from 1 up to the value of n. The yield keyword is used to specify what value the generator should produce when it's iterated over. Then it pauses the function until the next value is needed. The function state, including local variable, is saved between yields so it can pick up where it left off. When you use the generator in a for loop with count up to, let's say, 10, it prints the number 1 to 10, one at a time. It generates each number as the for loop asks for the next number rather than generating all the numbers at once, which would be less memory efficient. What is shallow copy and deep copy in Python? Well, in Python, deep copy and shallow copy are methods used to copy objects. When we use the equal operator, it only creates a new variable that shares the reference of the original output. In order to create real copies or clones of these objects, we can use the copy module in Python. They are of two types, shallow copy and deep copy. Now, let's focus on shallow copy first. A shallow copy is a copy of an object that stores the reference of the original elements. The simple way to understand this is it's like making a list of items you own. If any of those items is a box with more stuff inside, your list just mentions the box, not the stuff inside. So if you change the content of the box, it will be changed in both the original and the copy. Now let's come to deep copy. A deep copy is a process where we create a new object and copy elements recursively. The independent copy is created of the original object and its entire set of elements. Changes made in one object do not affect the other. What do I mean by this? It's like making a detailed list of items you own. If you have a box with more stuff inside of it, you list down all the stuff in the box too. So even if you change the contents of the box in the original list, it won't change in the copy. Explain the use of lambda expression in Python and when is it useful. Well, the lambda expression or function is used to define a function without a name in Python. It is also known as anonymous function because it doesn't have a name like regular functions do. The difference is that in a regular function, you have to define the function. Lambda is useful in situation where you need a small temporary function that you won't need to use elsewhere in your code. And this is how lambda function looks. Lambda function can have any number of arguments but can contain only a single expression. This means you have to write the entire thing in one line. One of the foremost use cases of Lambda is in functional programming, wherein it allows you to supply a function as a parameter to a different function. For example, map, filter. What is the use of pass keyword in Python? So pass is a null statement that basically does nothing. It is often used as a placeholder where a statement is required syntactically, but no action needs to be taken. So basically, it's just there to ensure your code runs without syntax errors until you are ready to write the real code for that block. Let me show you how. In this case, pass allows you to define the function myFunction without any actual code. This can be useful when you are sketching out a program and aren't ready to write the function yet. Write a code snippet to reverse a string. So reversing a string is a classic coding challenge that involves taking a string and flipping its character order. In this question, we'll explore a method to reverse a string without relying on Python's built-in reversing functions, demonstrating a hands-on approach to string manipulation. So we start off by creating a variable string1 containing the string which is to be reversed. So I'll initialize this. We then create an empty variable string2 that will eventually hold the reversed results. The for loop iterates through each character in string1. Inside the loop, we take the current character and append it to the beginning of string2 using concatenation. This effectively builds the reversed string character by character, and finally we print both the original as well as the reversed string to see the transformation. So here's the result that we get. Our string is reversed. Write a code snippet to sort a list in Python. Sorting data is a crucial task in programming. Python makes this effortless with the sort method, which can arrange the elements of a list in ascending order. Let's dive into how it works. We first create a list named mylist. It has three numbers, 3, 1 and 2, obviously in unsorted order. We then use the sort method directly on mylist. This method rearranges the elements of the list in ascending order from smallest to largest. It's important to note that sort modifies the original list in place, meaning it changes the order of elements within the same list. Finally, we print the mylist to display its sorted contents. And there we go, the elements are sorted now. How can you delete a file in Python? So Python provides a way to delete files using the OS module. This module offers functionalities for interacting with the operating system, and the OS remove function specifically allows you to remove a file. Exercising caution is crucial when deleting files. Once a file is removed, it's generally unrecoverable. Make sure you intend to delete the specific file before using this code. So let's say we create this particular text file within our runtime using this line of code. Once we do that, a file with this name text1.txt gets created in our runtime, as you can see over here. Post that, we import the OS module. Then we call the os.remove function on the text file we want to delete. This function attempts to remove the specified file. And if we check the runtime once again, the file is deleted successfully. Discuss different ways of deleting an element from a list. Removing elements from lists is a common operation in Python. Here we'll explore two effective methods. First one is the remove function. This function targets a specific element value and removes it from the list. Important point to note is if the element doesn't exist in the list, remove will raise a value error. Second method is the pop function. This function removes an element based on its index in the list. You can specify the index of the element you want to delete. And if you don't provide an index, pop removes the last element by default. So coming to the solution, we create a list with the numbers called list1 over here. Let's first use the remove function. We try to remove element 2 from this list, and then we print the updated list for observing the changes. Let's see what happens. As you can see, the element 2 is removed from the list. Now let's do the same using the pop function. Let's say we want to remove the element at index 1. Remember, indexing starts from 0. So we mentioned that, and again using the print function, we observe the changes. So as you can see from the already amended list that had these 3 elements, element at index 1, which was 3, is now removed, and we just have 2 elements. Write a code snippet to delete an entire list. Sometimes you might need to entirely wipe out the contents of a list in Python. The clear method makes this task effortless. Let's dive into how it works. We first create a list with numbers called list1 again. Then we simply call the clear method on our list. This method removes all elements from the list, effectively making it empty. Finally, we may print the list again to demonstrate that it's empty now, and it indeed is. Write a code snippet to reverse an array. Reversing the order of elements in an array is a common task in programming. Python offers a couple of techniques to achieve this, particularly when working with NumPy arrays. Let's explore 2 effective methods. To start with, we first import NumPy. Thereafter, we create an array called array1 with elements 1, 2, 3, 4. NumPy flip function reverses the order of elements in array1 and stores the result in array2 with this particular line of code. And finally, we print array2 to observe the changes. So as we can see, it is reversed. Moving on to method number 2. On the same array1 that we created above, we use this particular notation this time around. It is a special slicing technique that reverses the array elements without modifying the original array. Finally, we print array2 to observe the changes. Again, as we can see, the elements have gotten flipped. Write a code snippet to access an element, delete an element, and update an element in a NumPy array. Interacting with array elements involves accessing, removing, and modifying them. Python's NumPy library provides efficient tools for these tasks. Let's dive into how to achieve each one of these. First up, let's create an array with the name array1 having these numbers 1, 2, 3, 4. For accessing the elements, we use this particular notation with the index number in the square brackets. Let's say we want to access the element at index 0, and as we can see, we are able to access 1, which is the index 0 element. For deleting an element, we use this particular line of code, numpy.delete, and within brackets, we specify the array on which we want to make changes and the particular index value of the element that we want to delete. So over here, we are trying to make changes to array1, and basically we want to delete the element at index 0. Let's see what happens. And yes, changes are done. Lastly, for updating, we use this particular line of code wherein we specify the array and the index value, and we sort of declare the new value, and this modifies the original array for this particular element. As we can see, element at index 1 has gotten updated to 100. Write a code snippet to concatenate lists. Combining the elements of two lists into a single list is known as concatenation. Python offers several ways to achieve this. Let's explore a technique using the zip function and list comprehension. For this, first of all, we create two lists, list 1 and list 2 with the text elements. The zip function here pairs elements from both lists together, creating tuples like WE, ARE, and so on. The list comprehension, which is this, then iterates through these tuples, combining each pair of elements using the plus operator that we have in between these two. The combined elements are stored in list 3, and with the sprint function, we can observe the changes. And as we can see, we have successfully concatenated the two lists. Write a code snippet to generate the square of every element of a list. So creating a new list with the squared values of elements from an existing list is a common task in Python once again. Let's explore two efficient methods to achieve this. Method number 1, using a for loop and list comprehension. Within this, we create a list first of all with these set of numbers. Thereafter, the list comprehension, which is this, iterates through mylist, squares each element, and creates a new list called squared list. And finally, we print both the list to compare the changes. As you can see, all the elements from the new list are squared. In method number 2, we use the map function. The map function applies a given function to each element of an iterable. This lambda function is a short anonymous function that squares its arguments. Then map applies this squaring function to each element of my list. And finally, we wrap map with the list to convert the results into a list for clarity, and we print the changes to observe what happened. So as you can see, again, all the elements have squared. What is the difference between split and join? So here's a comprehensive explanation of the difference between split and join in Python. Split and join are both functions of Python strings, but they are completely different when it comes to functioning. The split method is used to create a list from strings based on some delimiter, for example, spaces. Here is an example of how to use the split method in this particular code cell. So as you can see, this particular string has been splitted into a list, and we can observe the changes. So as you can see, the split function has splitted this particular string on the basis of the white spaces that were there between the words, and a list has been created out of it. Thereafter, the join method is a built-in function of Python's string class that concatenates a list of strings into a single string. It is called on a delimiter string and invokes with a list of strings to be joined. The delimiter string is inserted between each string in the list when the strings are concatenated. Here is an example of how to use the join method. Here the list is joined with a hyphen in between. So there you have it. The next time you appear for an interview, I hope these questions help you ace it. And if you want an answer to any specific question, let us know in the comment section below and we'll get back to you. Hit the bell icon so that you do not miss whenever new video comes out. Till then, goodbye and happy prepping.